All right. Welcome, Gopi. I'm very excited to talk to you today about a conference that you've been organizing for about a year, I think now, the Renewal of Science conference that will be down in Mountain View, California at the Computer History Museum, beginning October 31st, All Souls Day, continuing through November 2nd. It's going to be a very special weekend. You've invited scientists and researchers, many of whom are coming over from Europe, bringing all sorts of equipment and exhibits. This is a real hands-on look at science from, say, a more experiential and phenomenological point of view. And so uh, let's start with just the initiative itself. Why this conference and why now?
Yeah. So for the first part, why the conference is very closely tied to why now? Because in the last several years, there has been so much of a social upheaval and so much of a discussion about the value of science to society. And at the same time, the social upheavals have caused people to rethink in some way where we are going as a trajectory. And many solutions are offered. You have the solutions that say do X in order to achieve Y because science says so, and that formula has been repeated in multiple forms. And on the other hand, you also have kind of an obscuration of what exactly science is supposed to be doing, because you have a very difficult relationship with politics on the one side, and you also have slogans such as believe in science coming out in the common person everywhere. So there is a complete, what you would say, Sturm und Drang. And in this back and forth, one thing that I was thinking about, along with a few friends of mine, is how can we provide something that brings clarity to this? How can we introduce something that not only just gives a different way of looking at things, but also a different way of participating and taking part in the events? And it also provides a little bit of a different view than the traditional view of the expert authority of scientific knowledge. And this is a temptation that all of us are always, in danger of succumbing to, because it is much easier with respect to specialist scientific knowledge to believe rather than to strive to understand, because the understanding seems inaccessible to us. And it also seems inaccessible because of the language most of the time in which it is couched, which involves a heavy amount of jargon or a heavy amount of technical terms, many of which serve to distance the average person from accessing science. So, in view of all of this, and also in the extremely, vibrant research work that has been done across the world, which has not seen the light of day for many people because of various reasons. Um, in putting all of this together, the idea of a conference came out. Okay, so we have to find a way to introduce something which is productive. We also have to find a way to give a platform for that kind of research, which is really transformative, not just superficially so. And at the end of it all, to very concretely give suggestions for scientific transformation leading on to a societal transformation. So a kind of uh, a small attempt at hastening another renaissance, if you will. So that's the background for all of this.
Yeah, that's a wonderful entry point. It's so true what you say that uh, we're faced with the challenge of finding a bridge between the expertise of a very specialized uh, set of scientific disciplines
Yeah.
and society, and addressing our very real um, problems as human beings by utilizing scientific knowledge, but finding a way to do that uh, where we can avoid just these slogans, trust the science, because science is a human activity.
Yep.
It's a cultural activity.
Right.
And as human beings, we're subject to all sorts of biases. And I think there's a certain lack of understanding expressed among the general public uh, from sort of both of the two angles you might take. Those who say trust the science don't always understand that there have been over the last few hundred years a proliferation of so many different scientific disciplines that just because you're an expert in one domain, as soon as you step 1 inch outside of that narrow domain, that scientist probably doesn't know anything.
Yep.
uh, but even those people who say, science is not the best way of knowing, or that they'd rather be more mystical and spiritual and think that science distracts us, or that the more empirical and uh, thought heavy, reflective ways of knowing just pull us out of that sense of participation in a living cosmos. There's actually something very important about science, right? That reveals to us how nature operates, but also how the human being operates and what we even mean when we use a word like spirit, right?
Yeah.
So why don't we go into a little bit of the details here? I mean, you have speakers who will be addressing certain uh, questions in physics, in biology and evolution, in physiology,
Yeah.
astronomy. Where should we start? Do you want to share a little bit about um, the unique alternative that you're trying to bring in inviting a
Yeah.
particular kind of scientist
Yeah.
to speak
Yeah.
on these issues?
Yeah, and that actually ties into where this conference is being held, in the sense that there is a purpose for holding it in the middle of Silicon Valley at the Computer History Museum. And that is because it is in many ways seen as the cradle of innovations in today's day. Most of the social changes that have spread across the world, so to speak, especially in the age of the internet, you can find the source point in Silicon Valley. So, in the same way, if we actually sincerely pursue the thought of innovation, we realize there is a big issue with the way we look at things is we tend to look at innovation only at its last step, at the most superficial level. We don't think of innovations in entire ways of doing science or entire methods of knowing that are used in doing that science. And we don't also always connect the difference that comes about in the final result, depending on how the method of science that we are using is applied. For instance, I'll give you a simple example, right? You have the very classic example of plastic, and very everyday and immediate in our face. We all know that the plastic comes out of the petrochemical process, and it is something that is made and very hard to unmake. So you have in that end product of plastic, which we see everywhere, and uh, we see the glut of it everywhere. The end result is actually the fruit of a thought process that begins in the first place, that decides to create a process only to make and not find any process that can undo it right at the beginning. We are biased from the get go. And believe it or not, a few decades back, um, when plastics were not yet, in vogue, and companies were trying to bring them into vogue, the argument used was you should save the trees and use plastic. Very, very inverse of what we currently hear. So, if the societal feelings about these things can shift 180 degrees like that, then there is an issue with the way we are dealing with any piece of technology. So, instead of going towards, what new technology can we bring about that will solve the problems that we ended up creating earlier, we ask, okay, is there a problem with the way we are creating these technologies in the first place? Is there a problem in the way we are thinking about these problems in the first place? Are we just trying to kind of scratch the itch and come up with a solution? Or are we serious about really solving something? So, with that in mind, I was looking for people who are looking at multiple scientific issues at their very basic level, and they're trying to do it in as well-rounded a way as possible. So that has been the, what do you call, the seed of the whole conference and the route from which we are bringing the people together. That has been the core idea. So with that, we have this spread of topics. And even though we do have a spread of topics in multiple streams of science, one thing that is common to all the speakers that are coming in is intrinsically they are not specializers. They are not people who are interested in putting themselves in silos and going only on that one thing. Even if they are experts in that one thing, they have a healthy understanding of several other fields as well. So even if they may not be as much of, say, a polymath as Leonardo da Vinci, they are precursors to that. Many of them have, expertise in more than one field. So that has been one of the prerequisites for calling speakers to this conference. Only those who have an intrinsic capacity to cross boundaries and not merely stay in their lane. So that was, the guiding principle for getting the speakers for this. So as a result, the speakers are truly some pretty phenomenal characters. And you will see that when you come to the conference and experience the presentations and the live exhibits and so on. And yeah, I would be happy to go into more detail a little bit topic by topic now, depending on what you think would be the best thing to start with.
So before we go into the specific topics, I think a general statement about the approach to science that's being taken here might be helpful because, as you said, each of these speakers will be, uh, if not quite the Renaissance man that Leonardo da Vinci was, um, because it's very hard nowadays, given how much science has grown and proliferated to actually integrate all of that knowledge. But nonetheless, I would say it seems to me that what they all share is the sense that, um, as Goethe put it, that the human organism with our healthy senses is the best instrument we could ask for to
Yeah,
really understand what is color, what is warmth, what is sound, and the way that contemporary science, modern science, has just gone head first into abstraction,
yeah,
uh, and abstractions that are powerful, that afford us great technological, instrumental, capacity to manipulate and control the world to some degree.
yeah,
Though there's blowback and consequences that
yeah,
we didn't know. But still, the knowledge produced becomes so abstract that the average person and even scientists themselves can't make sense of the knowledge that they've supposedly produced. It's a
yeah,
purely instrumental technical knowledge,
yeah,
uh, but not a comprehensive knowledge that makes us as human beings feel like we're understanding the phenomenon,
yeah.
right? So can you speak a little bit to this approach to science that takes our own experience of the phenomena seriously?
Of course. So I think the subject has to be tackled at the level of psychology. So, for example, when you're speaking of the scientific method, or you are speaking of the trust in our own senses, in both these cases, what we are speaking of is where is it that we feel grounded? Whether it is that we are feeling grounded in the scientific method, or we are feeling grounded, and we are feeling grounded in what the instruments tell us, or we are feeling grounded in what the senses tell us. And in all of this, you have the one factor that decides what we are going to do, and that is our own activity. How we decide to be active determines which one of these we, in a way, go after. For example, if I say, that instrument, say this particular microscope or this particular uh, computer extraction of data is 100% objective, and that is what I'm going to go with, what we may miss is that it is us who are saying that it is 100% objective. At the end of the day, we are still giving that criteria. We are still participating. If we say, I do not trust the sense, if we say that, then at the same time, we are also making a declaration about what we can and cannot trust. We are saying, I trust the instrument, but the instrument is again something you observe with your own senses. You still observe the graph on the computer. You still observe whether it gives out the right result or there is an error in the graph. You still decide that. So everywhere there is a human participation, which has kind of taken a back seat. And that is where we have to make the change. We have to bring it back into the front seat and say, okay, no, this is a critical portion of how we are going to do science. We are participating, we are actively participating. So there is that. And then the second aspect is what we speak about when we say the scientific method. What do people normally understand? They say, make an observation and then make a hypothesis, test your hypothesis with experiments, and depending on what the results are, see what you can understand out of it and share the results, right? So this is traditionally seen as the scientific method. And unknowing to most, right in the second step of creating the hypothesis, we have an issue. What is that issue? Compare the way we are doing science with, say, a conversation between one person and another, or just the process of listening to a conversation. Say you're in the middle of a cacophony of voices in a cafe and you're hearing one particular voice. First, you have to pay attention. And then you pay attention and then you listen. And once you listen, you are now in the process of trying to understand. And you don't try to understand unless you have heard all that other person has to say. You don't stop it midway and say, okay, I'm going to start figuring out what this person is trying to say right now. I'm going to make a hypothesis about what this person is trying to tell me. So if the hypothesis process starts off prematurely before the listening process is completed, you have an error in understanding. One easy way of saying it is, imagine somebody spelling out letter by letter a word, and they start with A, and then they say N, and then they say I, and then your mind goes, what is it? Anisette? Is it animation? Is it what is it? Then it's ANIM. Then oh, it's definitely got to be animal. It could be animate. It could be anything. And then I say ANIMO, and then that suddenly throws you for a twist, and you say, wait a minute, that is not going where I thought it would. And then the next letter comes out to be S, and you say, oh, it is leading towards animosity. So the whole trend, you see the number of twists and turns that we had to take, all of these are being caused because we are prematurely creating hypotheses. And that has been the bane of the scientific method as well, of prematurely creating hypotheses. And as a result, whenever the new letter kicks in, we have to change the whole meaning all over again. And many times we are not willing to do that, as the whole inertia of the institution kicks in, and the new letter O is not really taken in, as people still go with their favorite theories that had been conjured up beforehand. So this is what we are dealing with. And when you try to correct that, you say, okay, we need to be able to listen completely and allow that entire word, wait for the word to stop and wait for it and then ask your question. That is the actual experimental method. You first listen completely and then ask question and seek additional illumination with more words. And then out of that, you create an understanding. So this process lies at the heart of all approaches to the different fields, whether it is physics, whether it's chemistry, whether it's evolutionary biology or any other topic. This is at the root of it. We have to be able to let all the facts to have their place in the sun, and then be willing to entertain the possibility that the word is probably not yet complete. And so we ask additional questions, and once again, we wait. And this more patient and non-agitative way of doing science, I think, will provide a better foundation, because the answers that we discover in this method will be more in harmony with the world and be more in harmony with something that can help it. And whenever we don't do that, well, we have the results around us today to show for it.
Right. So, as an example of the problem here, you think of a certain hypothesis, say about um, particle physics, like the Standard Model, and a certain instrument is designed to prove this hypothesis,
Yeah,
a particle collider, billions of dollars, thousands of people working on this for a decade or more. And the instrument actually already has the expected result built into it in a way. It can only observe what they expect it to observe because that's how it was designed,
yeah,
based on this prior hypothesis. And so that approach to science, it might advance technology, but to what end?
yeah,
And are we discovering how nature is truly, or are we sort of distorting the facts, ignoring half the facts or most of the facts, and only looking at what we expect to see, where we're shining the light, and ignoring everything around that?
yeah,
Um, yeah, so this is a quite a big shift that you're proposing here to renew science away from uh, this instrument-centric approach,
yeah.
uh, to really look again at what we can observe of the natural world. So maybe you can lead us through choose a couple of examples of the inquiries which will be presented, just to give people a taste of what will
Yeah,
be in store for them if they attend this conference.
yeah. So one example is in the realm of color. So physics as such has kind of put the whole concept of color in the way in the back burner, or it's in an attic somewhere gathering cobwebs. So it's not at all something that is palpable in the present day for for most of the scientists. But in that attic, there are some things that can completely shake the whole foundation. For instance, there are colors called extraspectral colors. And these are colors that are not seen in the rainbow easily. And they are also not seen, when you use the prism and you see what comes out of it in a traditional Newtonian way. And in in the midst of all this, you also have a way of looking at color that creates polarities within the light spectrum itself. So normally, when you think about a spectrum, you think about a line. So when you think about a line, it just keeps going on increasing or going on decreasing. That's a linear thought process. And what you find when you explore the science of color a little bit more, that colors like magenta, which are a complete mystery to modern science, actually holds the key to a complete revamp of the way we understand the color spectrum. And not only that, in itself, it also holds the key to completely transform the way we look at the electromagnetic spectrum as a whole. And today our entire world is immersed in technologies that deal with the electromagnetic spectrum, depending on one end of the spectrum or the other. In fact, more than any other time in history, our technology is more in this spectrum than anywhere else. So once you change the way you look at color, you end up changing the way you look at the spectrum. And not only do you start seeing things which are polar opposites within a process that's normally thought of as linear, now you start seeing like the other half of the coin that helps balance out what you saw in the first place. So the spectrum becomes a circle rather than a line. And this change, this shift in the way you see the color spectrum involves other changes also in the way we understand what is called a photon, the way we understand what we call entire domains of optics, of diffraction, of refraction, of all of these different domains. All of them undergo a corresponding shift. And there are researchers who have done excellent work on this. One researcher who will be joining us is Dr. Matthias Rang from Switzerland. And he has created a wonderful exhibit that has been displayed in multiple cities in Europe, in Sturbridge in London, and in Germany, in Switzerland, and in Scandinavia. So this big live exhibit with pretty huge prisms, I might add, is going to come to the United States for the very first time as he brings this over and uses that to show people how they have a different way of looking at color. It is not just a trick of the brain, as it is called, or something that is an illusion, or all of these judgments that have been passed on it. They kind of melt away in the light of things that you can directly perceive without losing your objectivity. So that is one subject, and there are other researchers too who have done excellent work on that. Remus Poradin from Australia, I'm hoping to bring him over as well, has done fantastic work in showing the polarity between the red and blue ends of the spectrum. And he's also done excellent work in what is traditionally called the subjective spectrum and what we see when we pass light through a prism and let it fall on a screen, which is the objective spectrum. He has been, I think, one of the first ones to show how both of them come under the same overall umbrella, and one is not as subjective as it is made out to be. So we are basically talking about completely transforming not only the science of radiation and light and color, but also the invisible aspects of the spectrum as well, if we follow this route consistently. So that is one clear example of what we are bringing in. Another one is also in the sphere of uh, chemistry. And in chemistry, you're looking at some fundamental chemical reactions that don't behave the way our view of chemistry today dictates that it behaves. And this is where Professor Hasok Chang from the University of Cambridge, he's the history of science head of the department, and he has this unique capacity to identify all the different roads in the history of science which were not taken, even though they were really valid scientifically. It wasn't taken simply because the general thought of the day moved in one particular direction, and this simply got left out of reckoning. So he has figured some of these things in multiple subjects, and in chemistry, he has figured out how chemical reactions don't really agree with electronic theory, dot for dot, as we think it should. Since the time of Faraday, we have had this view of chemistry as just a modified form of electrical reactions. So chemical reaction is seen as just another form of it. And what Professor Chang points out is how that doesn't do so. And he shows experiments that in turn point out the big shift in direction that that brings about. Now, with that, of course, everything changes in the whole realm of, say, battery technology, or things that happen to do with corrosion, or all the chemicals that we tend to use day in and day out, many of which have pretty insane effects on the environment as well as on the people, because we have a one-sided view of chemistry. So how does that change if you start taking a different view? So if you want a single thread to connect it all, you can just say bringing the other half of the coin to view, so that you know the actual value of what you're holding in your hand. And what Matthias does in color, Hasok will be exploring in chemistry. And I can wait if you have any thoughts before launching into the biology part.
Well, I love that you're having a historian of science, Professor Chang, come and just explore all of these alternative pathways that research could have gone down.
Yeah.
Because we think that there's something inevitable about scientific progress, that it's
Yeah.
just marching closer and closer to the truth.
Yeah.
But there's so much contingency in that process, and political, economic, and cultural influences over how science develops. And, you know, the possibility of a post-materialist science, say, rests largely on a kind of cultural transformation that allows us to see in a different way how science and a scientific account that's satisfying to us, what that even looks like. There's a
Yeah.
certain emphasis in the Western world, especially over the last few centuries, on industrial applications. And so it became more important to rush to the technological payoff, at least the short-term payoff,
Yeah.
than it was to really understand what it is that you're manipulating, right? And
Right.
so
Yeah.
plastic was the great example you gave to begin with. What a problem we've created for ourselves with that one.
Yeah.
Um,
Yeah.
so yeah, why don't you share a bit about this alternative approach to biology and evolution?
Yeah. So in this subject, we have something that touches us even more closely, because with physics, yes, we kind of observe things more or less outside ourselves. Chemistry, similarly. So, but biology, when you come to biology, and especially evolutionary biology, that comes into place with respect to our own standing in the world. So when you look at the historical ideas such as Charles Darwin's ideas and Wallace and all of that whole evolutionist ideas, some of those ideas have led down some pretty dark paths. And you know that the Darwinism was the foundation for the eugenic sciences of the day. And today we have this weird schizophrenic situation with regard to it, because we are still carrying forward the tenets of Darwinism while trying to dissociate ourselves from the consequences of those tenets. So we are in this very peculiar situation. We do not want to clearly say where humanity lies with respect to the animal kingdom. We don't want to make a distinction very clearly there. And the idea is always that, a human being is pretty much just a evolved animal. And everything that we see based on that idea, including the struggle for the survival and survival of the fittest, all these ideas that have percolated into society, they have affected our social relations big time. But at the same time, we have not gone back to the science and checked whether the conclusions Darwin derived from what he observed were correct. We have not looked at a different way, the other side of the coin, at looking at the same set of bones that he looked at and trying to see, was there a different message perhaps? Was there a letter O that was coming out after that, or a letter E coming out after that? We have to see that. And that is what we are doing with the presentations on evolutionary biology, which will be given by two presenters, one of whom is from Germany, Christoph Hueck, and the other is from here, from the US, who used to teach at Prescott College, Mark Riegner. Both of them have spent years and years studying the forms of animals and the forms of the human skeleton, as well as the forms of birds in the case of Mark Regner, and identified how the physical forms themselves can tell a totally different story. They look at the relationship between the juvenile forms of animals and the adult forms of humans and compare and contrast how different bones are built up in the animals and in humans. And the live exhibit will actually consist of big skeletons and different parts of the skeletons of different species and so on to show very clearly what exactly is happening between animal and man in the actual bones of the skeleton. Are we correct in saying this is a more evolved form? Are there exceptions that turn the whole thing onto its head? What is going on? So this is something that has repercussions across the globe because the way we think of humankind and animal kingdom cascades into the way we think of humankind as such as well. And so the kind of mentality that we have had, one thing we miss is when we say something like, okay, you know what? We are not that different from animals. We are just a highly evolved form of animals. We don't realize that even there, we are putting our human understanding front and center without realizing it. We think that we are the same. And in that sentence, we have not asked the animal the question. So we cannot help but we cannot help avoiding taking our standpoint. And if we are indeed taking our standpoint, let's do it responsibly. Instead of trying to say that, no, we are not going to take everything from a humanocentric standpoint, and in the process, falling even more prey to it and the back end because we cannot pull ourselves up by the bootstraps. Everything we look at, we have to come at it from the human standpoint. That is the only standpoint we have. So let's do it honestly. So let's actually look at the data, actually look at forms of interaction even between animals and environment, humans and environment, interspecies interactions as something more than just the survival of the fittest or the struggle for survival, and see if there is a different idea. What comes about if we look at it from the side of cooperation? What comes about when we look at it in terms of both devolution and evolution? So that gives the other side of the coin. There is a devolution that is accompanying evolution, and we are looking at the placement of humanity in the light of both of these streams, not just in one of these streams. So that is what we'll be exploring in the conference in great detail. I don't want to steal the thunder of any of the speakers, but that's where they'll be going.
Yeah, so interesting. Just to reimagine the place of the human being and maybe come to see anthropocentrism less as a bug
Yeah,
and more as a feature. We can't escape it.
yeah, yeah,
And so, how can we explore and come to understand the biological world as though, um, in some sense, we are a part of it, but in another sense, we're the ones asking these questions.
yeah,
um, I don't think the animals are asking these questions. And so, what is it that has given the human being this unique perspective?
yeah,
Um, and you know, a quick little thought here about Darwin and the way that he was drawing on, British economists,
yeah,
Malthus and Ricardo and Smith, and sort of, taking the way that human social relations were developing in Scotland and Britain, and in the way that anthropologists would look at exotic non-Western cultures and say, oh, they're animists, they're taking social relationships among human beings and projecting that onto the natural world.
yeah.
Darwin did the same thing,
Yep.
right? A particular culture's way of thinking about human competition in an economy for scarce resources was then projected onto nature writ large
Yeah.
as the engine driving the whole process.
Correct.
Um, and so we really need to be aware of our projections and take
Exactly.
a broader view of the human relationship to the rest of the living world.
Yep. In the case of Darwin, like you said, Thomas Malthus was one of the sources for all of those ideas that finally took shape in the origin of species.
Yeah.
And uh, this aspect of projection brings us back to the point about psychology I was trying to make earlier. Unless we take the psychology of the scientist seriously, the scientist is always lost in a hall of mirrors of his or her own projections. And of course, there'll be a lot of mirrors, so there'll be a lot of terms, a lot of jargon, a lot of things that one can use to say we have a very elaborate science. But it is still many times a hall of mirrors. And this is the way to undo or pull back those projections and be actually even more objective than science is normally prone to be. So all of this you can think of as upgrade to the objectivity of science. That is what we are actually aiming for. Uh, Without knowing it, it has gotten lost in multiple ways in these hall of mirrors created by projections, and we're trying to get it out of the maze so it can actually see the phenomena even as straightforward and simple a perception as the forms of skeletons and figure out where it goes. So yeah, that's what it has with biology. We will also be talking a little bit about, the role of humans per se with respect to their most recent creations of artificial intelligence, and to understand where that leads and how we place ourselves. Once we know how we place ourselves with respect to animals, now we ask how do we place ourselves with respect to machines. And so that would be more in the later part of the conference, subject that will be dived into. And there will be Gary Lamb, who will be a speaker on that. There will also be a discussion, mostly from some couple of other people. But yeah, this is something that will be very, very critical.
Mm.
And yeah, go ahead.
It's tremendously comprehensive. Yeah, as we wrap up this conversation, can you speak to a little bit, speak to who you think would be interested and who might benefit from this? Do you would you like to see uh, practicing scientists and scholars and students and like who's the audience that you're trying to appeal to with this conference?
Yeah, well, it definitely includes students and practicing scientists, but at the core, I'm looking for those who have had a fascination with some part of science in their lives, and they might not have always had the opportunity or the wherewithal to pursue it to their satisfaction due to various reasons. Maybe they felt it was too abstract. Maybe they felt their life circumstances determined that they can't take this route right now. They're to get a much high paying job or something and go in that way. Or, it is something that they couldn't fully grasp because the thought felt off to them. Not just a matter of, it being something far away that you cannot understand, but you actually felt that something was off in the way things were taught at school, or in the way things are, spread on the internet, or, how you would come to things on Google today at the click of a button. If there is a feeling of dissatisfaction with the way science has been separated and kept in the ivory tower, more or less. If there is that sentiment, those people should find great value in this conference. Because what we are trying to do is to essentially build that bridge and remove that ivory tower, so that that healthy excitement on science that we had when we were, I don't know, in high school or whatever, or even earlier, that is something we can still bring to the forth and provide a way to, access this material without being handicapped in any way. And so, yes, and high school and above, students, teachers, just people who are just looking at the latest scientific discovery once in a while and want to know more about it, or people who are concerned about the way technology has affected the world and they want to change it. And they say, okay, no, you have damaged the environment a lot. So what can we do to resolve it? The people who have a feeling that we are out of harmony with nature. So it's a wide spectrum. We are not particularly focused only on those in academia. Those in academia are very welcome to come, and we do not want to leave out those who have these kind of subtle feeling of, there may be a different way of doing this. This is exciting. I want to get entry to it, but how do I do that without going through a 10-year PhD and all of that stuff? So that would be the demographic. Those who have a spark of enthusiasm for science as such, to know how the world works as such, and to see if they want to get in on the ground floor, so to speak, of how to do it differently.
Wonderful. Yeah, it's a great invitation. I know I look forward to being there. Is there anything else that you'd like to share before we wrap up here?
Oh, just that the early bird tickets are on until August 31st for the general audience, and for students in particular, it will be on till the end of the next month, till September 30th. And I would encourage folks to get their tickets quickly and make sure that they make use of the early bird offers, and yeah, join us at the conference in Silicon Valley.
Awesome. Yeah. And I will certainly link to the conference website and registration page under this video.
Yeah.
Gopi, thanks so much for sharing your knowledge, and thanks for this initiative. That's going to be, I think, a really important conference that I hope reaches a lot of people.
Yeah. Thanks a lot, Matt. Yeah. Thanks for the opportunity.